Hey everybody, Royce from Country Hill Seeing Wood, yep, Hill, you know. Okay, so another video coming today. It's been a while since I posted one because I've been doing this huge cabinet job. And today's video is basically just another step in me making this upgrade better. And it's really only gonna apply to a few people because how many people out there have a Onefinity CNC upgraded with a bracket that goes, a dust boot that goes behind the CNC. So that's not everybody, you know, it's a lower portion. But I really made this video more about learning Fusion 360 because that's what I made this on. I chose to make this little bracket on Fusion 360 because it allows me to get way more detailed with the dimensions. So here it is, and I'm gonna zoom in real quick and show you, you know, what I got going on here. Oh, and by the way, I am going to leave the file so you can have it for free. And then there's a clamp up there, which I'll show you that I'm gonna leave you the file for as well. So, you know, hey, free stuff. Okay, so this was the problem. I was like, how do I have a clamp that holds my hose up to connect to my rear mounting dust collection? I like having rear mounting because you can see what you're doing. For one, I video everything that I do, and two, I just like to see it to make sure that everything's going fine. So I had on the previous CNC a Kraken front boot, and you can't see anything that's going on. No offense to Kraken. So this one is an Ugly Dog Ultimate Dust Boot, and it goes behind. It has a lot of area where you can see if you got something stuck in there. It goes behind the rail. This track is also Ugly Dog. But it stops here, and you have to have a way to link it up here, or when you traverse over to the side, your hose is just gonna pop off. And then I also needed a way to keep it from squashing, so I made this little boot here, right? So this was the original idea, right? And I said, well, the hose only gets pressure this way. So if I turn the circle that way, then when I come over all the way to the side this way, then it'll be applying this pressure here that'll keep the magnets locked. And I know that that looks like it's touching the back rail. It's not. It's got like a millimeter or two. So I'm gonna walk you through how I made this, and then you can either make the file yourself, or you can grab the free one that I'm gonna post. I don't really care. I give away stuff all the time. Please do not start selling my design. One thing to note real quick is that, so this cutout here is for the probe. So you gotta have that. And then you'll notice I've got these bolts with 2 washers, and oddly, I found that these is what you see there. This is the M6 1 by 25 millimeter. If you go to 20 millimeter, it's not long enough. If you go to 30 millimeter, it's way too long. So 25 is the closest you can get. And then you get these M7 metrics washers, and that gives you the correct space, because you have this right here that will bottom out that bolt. So you have to have like a 23 millimeter or it's not going to work. And that's where those 2 washers come into play. All right, here we are in Fusion 360, and we're going to start a sketch. And it's always complicated. Just go in from the right side and over to the left, and always click that left one. And it's going to be the face that you want. I know that's a sticking point for a lot of people, but if you're doing regular CNC work, that's the one you want. So I'm going to go ahead and build epically slow the dimensions of this bracket, and you can follow along. You can make it yourself. On my website, I am also going to put up the little piece of paper that I showed earlier, and you'll be able to do that that way. I'm not going to use any hot codes, but you can see that I'm putting the hotkeys up there. I find it really cool to be able to make something that I'm missing for my shop with the CNC. But I mean, that's what CNC is. It's manufacturing. And I'm hoping with, all the changes in stuff being built in the US, hopefully here soon, we'll see a lot more usage for home slash hobby manufacturing because it has a place. I have contracts with people right now where I make little parts for them all the time, and it's great. If you can learn some of these skills, you can really do some awesome stuff with this. So here's my circle. I put it at 4.25 inch. I tried it once. Actually, the one that I show you in the video is at 4. And it was a little tight, so I made it 4.25, and then a half inch offset on that. This line is just a guideline that I'm going to use to bring the circle over. So I'm going to select it all, move it over, get it right about where I want it to be. This is probably the only not precise part of this whole thing because I get just kind of guesstimated where that should be. And now we'll go clear some of this up. I'm going to extend the lines, and you'll see what I'm doing with it real quick. Every time I break off of a line, I'm just hitting escape. So I hit L again. Well, of course, for this tutorial, I'm showing you me hitting the line button up there, but so I have everything. You can see basically what the bracket's going to look like. Now I'm going to go trim everything that I don't need. Turn off constraints and dimensions over there just because they get annoying. And, oh, what'd I do? So Command Z goes back. I just trimmed the wrong line. And we just continue to clean it up. There's a lot to do. I always make a mess when I'm making something like this, but I think it's fine. And then we're going to make a couple of these half-inch circles. So I'm going to grab that, and then I'm going to do Control or Command C, Command V to cut and paste or copy and paste. I'm going to put them in there, and then I'm going to use the tangent constraint. Click on my line, tangent, and it'll snap it to that line there. I don't use I'm not going to show you the tangent shortcode because it's kind of complicated. You can do a lot with tangent. So there's not just one little option. There's a couple little options that you can use. So it's easier just to push the button. See there, we'll select it and then click tangent again. Boop, and it'll just pop it over. And because those two circles are a half-inch apart, it's actually uh, welding it to both of them. And then we'll come over here with our trim and cut out these two spots, and that whole thing becomes open. Finish up the cleaning up, and you have the basic shape of the bracket. So I don't know if you actually saw that, but I switched from the Untitled to the old one so you could see what it looked like, and now I'm back on the Untitled, which is our current project. Now I am going to do a fillet on these two corners. And, a lot of people would say that, well, that's a chamfer. In Fusion 360, I believe chamfer is usually discussed in terms of three-dimensional. And then I made them a 1/4 inch diameter, and that's it. So now we're going to go over here and start building the spot where the probe goes. Make another rectangle starting from that original line, and it goes out 1.25. Could be a little smaller actually if you wanted to. You could make it like 1.23. And that's where your probe's going to go. So we'll use that box to carve it out. And now we're going to make the uh, bit holes, I guess you would call them. And what I did is I took that piece of paper and I put the probe on top of it and very carefully measured uh, the dimensions. And what it turned out to be was, I believe, 1.25 by 0.5. Oh, from the outermost corners. And of course, there's 4 corners on the actual Onefinity uh, top. So we build these 4 little rectangles. It'll take me just a couple more seconds. 5 inches is a bit much. 1.25, there we go. And those are just to tell us where to put the circles, where to put the drill holes. So now we're going to go over here with our circle, go to that corner and put a 1/4 inch. The holes for the screws need to be right at a 1/4 inch. They could be slightly smaller, but then, they're going to be tight. So I would go with a 1/4 inch if you're doing this. Works pretty good. And there we go. Now you can just delete or trim all those extra lines, get rid of them. Since we're in such a exciting part of this build, I'd say like and subscribe if you enjoy my content. Please leave comments and questions. So now we're going to extrude this. So we're going to go and grab it all and hit E for extrude, and then we're going to put in our depth, which this was 0.694. That's the thickness of premium ply. And I'm just going back and looking at the old version and new version. They look almost exactly the same. It's just a little more polished. And everything looks boom-de-bar. All right, we're going to head over to the manufacturer tab, upper left, and make our setup. And this is basically just designing what our material is and where we're working off of for our XYZ. I select box point, and then I select the, I guess, bottom left. At the top of the material, that's what I use for the Onefinity. For the Laguna, we use the base of the stock. And then I go to fixed size box, and this is basically going to ensure that your entire component is covered. But I like mine to be a little bit larger, so I add 1/2 inch. It's going to make it just a little larger, and when you're using a 1/4 inch bit, it makes sense. And then the 0.694 is the thickness of our material. And click OK. So now you have your setup for manufacturing. All right, and so here you can see just how the stock covers the part and why I add that little 1/2 inch. It'll give your bit room to cut without cutting off the material. So now we're going to go in and we're going to work on the face, which is the part where the probe goes into. And I don't really know why, but I had a little issue selecting it. Now you see that red arrow, that has to be, so we're cutting on the inside. That's what we want, inside of that rectangle. So you got to make sure that red arrow is on the inside. We're going to go select our bit and kind of again, I think I said it before, I probably should have used a compression for this whole operation. But honestly, I was just trying to get it done because this is one of the things that was preventing me from running my machine. So I always check the heights and then awkward pause. We need to discern where the top of our face is going to be cut from. So I like to do the selection and then I'm going down 0.395 so you can see that negative 0.395 and that'll be the depth. So we'll look at all this, everything looks good. Maximum step down. I have a 1/4 inch bit, so I'm willing to do an 1/8 inch. That looks good. A lot of this stuff you don't need to mess with. I always preserve rapid uh, feed rate, and there we go. Oh wait. All right, so you can see that it's removing the material on the outside of our rectangle, which is going to cut into our actual piece. So we'll go back by clicking on the logo and you'll see that pass direction and just make it 90 degrees so that we're cutting off the material. And there you go. We're cutting into our stock instead of our piece. We'll run a simulation, right click. Oh wait, what are we doing here? We're gonna run a simulation. I don't know why that was in there. I think the simulation is a great idea because you're always going to catch things that you did wrong if you did something wrong. And then that info tab, which I didn't show you in this video, will give you an estimation of time and stuff like that. And here you can see the depths of cut, how it determined to go in. And that piece is done. So now we're going to go into drilling. We're going to drill out those 4 holes. And it's, I really love the drilling, I don't know, abilities of Fusion 360. You can actually make screw holes and everything. I like to do the select point, uh, really just for the reason that it's easy to get the points. If you're using the hole, you've got to click it in just the right spot or you're not going to get it right. We're going to go to height again, and we're going to select the whole top. We're basically doing the same as the last face movement. And we're going to go all the way through it, so it's 0.694. You could go all the way through with that drill tip through, but you don't need to. And then we're going to do the deep drilling full retract. And so what the deep drilling full retract does is that bit will come up to the surface every single time, which allows you to remove all that material. Now with plywood, are we really concerned about that? I'd say no. You could probably just dive your bit down in there and it'll do just fine. But I like to use it as a habit. It is the better option, especially if you get into metal.
Retracts. So because I made this with the outline on the bottom, I had to do the selection.
I'm just checking everything.
And the selection for the bottom height. Top minus
going from the selection, which is the top face, down,
tip,
and there's the breakthrough.
Super small. It's definitely not what I
want. 001.
Just go ahead and make sure it goes all the way through. And then here, I did the deep drilling. Because it full retracts.
I don't really know why I'm showing you all this again. I film this as I'm working it, you know, and then I voice over the Fusion 360 parts. It just seems to make things work better for me, but I guess I caught myself doing something dumb here. Apologize, I wasted 30 seconds of your life. So I'm going to simulate again. With holes, I like to go to the side.
And I'm going to do this kind of slow so you can see what a peck is. And you'll see.
And that's incredulously slow. And you'll see that peck, it's going down and up.
Clearing out the stuff.
And we'll go all the way through. Right. Making sure that we're not going way too far. And I sped it up at the end, and that's why you only saw 2 holes, but that was actually 4. So the last thing that we're going to do is the 2D contour. I like turning it on this side. It makes it easier to select the line you want. So I'm going to grab my tool again. I'll make a video here very soon about how to load tool databases into Fusion 360. I've actually found that the video I made for Vectric,
this one doesn't.
God, people use it every day, so I'll do the same thing for this one. Now you'll notice there, so I'm clicking Shift and selecting the rest of it because it only selected one part, but now it's got all of it. Make sure that that red arrow is on the outside because we want to cut the outside of it. You can get fancy with all these different things that you can do, rest machining and all that. It is not necessary for this. We're going to do multiple depths. Again, I have a 1/4 inch bit, so I'm very comfortable with anything 1/8 of an inch.
I don't really need any of this. This
no need for smoothing, stock to weave. Everything is
extra stuff.
It's just not needed on something this simple.
Preserving high feed rate.
Preserve rapid retract.
Lead in and transitions, and you'll see that in a second.
And then the only thing I'm going to mention is that preferred lead in.
And then
it's good to know information. It is not needed for this project.
I don't think so.
And then I also ramp a lot, but this is plywood.
See this little scoop?
Don't really need to ramp for plywood. That little area right there, see where the bit's going in and out, that bump? That is the preferred lead in as it's currently set. If that bump was somewhere else that would affect your model, that's where you would want to use that preferred lead in
And that's
ability.
how fast my machine's gonna run.
So there's my simulation. Everything looked really good.
Simulation, and it's all good. So we have our 3 files.
So and now we have our piece is finished. We are ready to save it. You can save if you have 3 different bits, then you can save this separately. But I decided, and I'm being lazy here, but I decided I was going to use 1 bit for all of them. Probably should have used an upcut for the drilling and compression bit for the contour, but I was being lazy. So if you select all 3 at the same time, highlight all 3 of them, and then go to process NC program, you can put all of these files into one. And they will run simultaneously, well, not simultaneously, but sequentially, one after the other. So give it a name, make sure your location's set, and save. And you see your NC code was successfully posted. And that's it. So I set my Z, or my X and my Y, just based off a location, and I set that on the screen in my Onefinity. Then I did my Z with the touch probe. Load my file. You can see it all. It's all one file. Really cool. If you had a ATC, a tool changer, you could do it that way as well with one file. So I'm starting with my, so that was the override tab. And I started with my feed slow. And you'll see as I'm going,
This is the arm bracket that I'm doing. As you can see,